Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot, and in this video I want to give you a quick tutorial on how to fly the A2A Comanche with a little bit of pilot input. So, in this tutorial I aim to cover how to operate the airplane properly and how to make proper use of the features available, especially of the tablet and the checklist within it, how real private pilots would use them, and finally, what I do not want to cover in this video is the in-depth stuff that A2A has already or is currently creating tutorials about. So, for example, for engine management in cruise, A2A has done an excellent video. I could not have done it any better. For that reason, I will refer to it when it becomes appropriate. Alright. So, we are sitting at Heidebüsum Airfield in northern Germany. We are going to do a quick way out. We will do a couple of exercises in the air that will familiarize you with the airplane, just like a real instructor would tell you to do. And then we are going to talk a little bit about some touch and go training, and finally we are going to land and shut it down. Alright, let's head straight into the cockpit and start with a couple of the procedures. So first things first, in private aviation, or in recreational aviation I should say, procedures are normally executed by the read and do principle, and checklists are written for that. So if we have a look at the iPad, you will notice that we've got the flight info screen down here, where we have first of all some speed and power settings that you should really memorize, but you have them available quickly on the iPad if you need to. And then you have the checklist, and these checklists are done or are constructed for the read and do principle, and that is how we actually fly those aircraft. So let's go straight over it. Before we start with our checklist, however, we can go ahead and do our walk around, so let's start with that. In order to start the walk around, we just need to do a few things. First of all, verify our parking brake is set, verify that the magnetos are off, very important, and we are going to release the control log. Finally, we need the flaps out, as we are going to check them, and with that done, I would say it's about time to head out our airplane. Let's take the tablet with us, and it's going to guide us right through it. Okay. We start on the right-hand wing, and we are going to check the flaps. So click on them and move them a little bit, just to be sure everything is attached and everything is safe over here. Then we go on to the aileron. Again, you will notice it has a little bit of play, which is totally normal. But it also moves into the full extent on both sides. On then to the tip tank. Have a quick look into it. There shouldn't be any fuel in there, and indeed there isn't, but we always want to confirm visually. So that's this. Then we are going to go down, and as you can see, we cannot drain any fuel of it either. Okay, perfect. So the lights on the forward right wing are okay. We are going to untie the airplane and have a look into the main tank. So never trust the needles. Never trust the fuel gauges on small aircraft. They are notoriously incorrect. You always want to have a look directly into the wing. That is the only source you're going to trust. At this point, by the way, also remember how much fuel there is in each wing, because that will help you later on to decide which fuel tank to use first. Okay then. We're going to remove the chocks, have a quick look at the main gear, no visible damages, no nothing the likes. And drain some fuel on the wing. Or so we should, provided that I actually opened the tank valves. So, like so, that should work. Okay then, engine compartment, fuel. And you can see, it's only fuel that we're getting out of this. There is no water in this. That's the important thing. Okay. Can put that away and close the hatch again. Perfect. We move to the front. Check that the propeller blades are all looking good. No visible damages over there. Nothing nisting in the engine inlet. Then moving on to the oil. Again, A2A has or is creating an in-depth tutorial about oil and colors and quantities. So for that reason, I'm just going to say we check that we have sufficient oil quantity over here without, and it's not totally black. If it's really becoming black, that's when you want to do your oil change at the very latest. Again, A2A is going to have a more in-depth tutorial about the oil. Okay, so we're done with that. Let's move on to the left-hand wing and have a look into the tank. You can notice over here that there is not as much fuel in here as there is on the other side. So, for that reason, we can already prepare our mind that we're going to use the right-hand tank at first during our flight. So, keep that in mind and be sure that the fuel quantity is sufficient for the flight. Okay then, going to move down. Once again, we check the landing gear for any visible damages. And yes, in my time flying A2A aircraft back in P3D, I did actually find a couple of damages to some of my aircraft. So it is worth it doing those checks. Alright then, let's move on. Untie the plane and remove the pitot cover. Lights are looking good. External tank. Let's have a very quick look inside, and there is nothing in here. That's just about as expected. For that reason, we can't drain anything off it either. Okay, the aileron once again. A little bit of play, but moves nicely. Perfect. Same thing on the flaps. The static port is looking good. And then we get to the stabilizer and just about check it as well, but don't touch the trim tab, that can really damage the plane. And finally, same for the rudder, and we untie it. Okay then, the other static port is looking good, and finally we can load up our luggage as we need. Today I don't expect too much, so it's just going to be a quick training flight, so we are going to take our own stuff, and we'll just about take the toolbox, just in case anything happens. Okay, perfect. And with that, our walk around is complete. So, you've got an instructor on the right seat, the baggage we just about loaded, and the fuel in the wing tanks as desired. Center of gravity is within limits, and that's all we need to check on here. So, let's go ahead with the checklists. Before engine start checklist. Preflight complete, passengers briefed, seatbelts on or secured, control lock removed, parking brake set. To set the parking brake, you will need to press the brake pedals first. So look at that. If I'm releasing it now, I cannot just set it again. But indeed, I first have to push the brakes and then I'm able to set my parking brake. Okay, gear switch, down, flaps, up, radios off, autopilot master off, avionic master off, all electrical switches, let's have a very quick look, off, circuit breakers, you find them below the panel down here. This is what it would look like if its circuit breaker was popped, so let's make sure they are all in. Okay, circuit breakers in, rotating beacon on, and that is down here. And that's the before engine start checklist complete. So again, engine start checklist, all read and do. And this is one, however, that we should quickly read over before we start the actual start sequence. So, fuel selector, desired tank. Remember what we said earlier, we had less fuel in the left tank, so we are going to start on the right-hand tank. Do not use them both at the same time. There is a huge problem in that they're interconnected. So if you're flying a turn and you are not properly coordinated, then fuel might flow from one tank to the other, quickly bringing you out of balance. For that reason, we're only going to use a single tank, even though you are technically able to select both tanks. So we're going to start on the right-hand tank today. Okay, so fuel selectors, desired tank, mixture, rich, prop, throttle, cracked, prop, full forward, carb heat off, that's the one down here. Okay, before we fire anything up, let's quickly read through it. Master switch on, fuel pressure check, fuel pump off, primer 1 to 5 strokes, magnetos both, prop area clear, starter engage, all pressure checked, mixture lean as required. So that is quite a standard startup procedure for those aircraft. Okay then, let's go ahead and do it. Master switch, on, fuel pump, on. Have a look at the fuel pressure gauge down here. And you can see fuel pressure is rising. In other words, the pump works. Okay, fuel pump back off again. So primer, 1 to 5 strokes. Now, how many strokes you need is something that you really need to determine based on the situation. A2A has some excellent covering on that, so I'm not going to go into much more details. Okay then, so primer. First of all, turn it, as that basically unlocks it. Now let's just about give it 5 strokes. And very important, lock your primer again. Very important. Okay then. Let's go ahead with our startup procedure. So, magnetos, both, prop area, clear. Okay, starter engaged. So, when we engage the starter, the engine might not start immediately, and that's totally fine. However, if you have concern that it doesn't start at all, people love to start pumping on the throttle. And indeed, you will get it started with it, but do yourself a favor and do a little bit of research as to what that does exactly and what the logic is behind it. So, just a little bit of background research there that I can certainly recommend if you want to get into it in depth. Okay then, throttle is tracked, let's give it a start. And here we go, engine is running. So between 800 and 1200 RPMs. I just like to give it 1000 because it's an easy number and it is right within the middle of where we are allowed to be. Okay, so immediately when the engine starts, check your oil pressure. Without oil pressure, shut it down straight away again, otherwise you're going to break your engine and that's going to get expensive. Okay, and finally we got to lean a little bit. Personally, I just like to pull it off a tiny bit. It just makes the engine run a little bit smoother on the ground and it prevents plug fooling. Okay, with that the engine is started and we can run our taxi checklist. So, primer, locked. That's what I said, very first thing there. Okay then, avionic master, on. Check the ammeter. And we want to see that we have a positive amperage here, as it indicates that our... I'm calling a generator for the purpose of the video. I'm sure somebody will say something about it. So let's make sure that we see a positive amperage there to check that our generator is working. Okay, the computer asked us if we refilled any fuel, and if we did, we are going to click the refuel button down here. We have a couple easy options. Fill 60, which is 60 gallons of fuel, so wing tank's full. We got fill 90, which is 90 gallons of fuel. Wing and tip tanks full. Then we can go into a manual mode over here, where we can use the change button, or rather where we can use the adjust button in order to change it manually. So let me show you. We go to adjust, and then for example 52.5 gallons is in there. Let's see what we actually have in here, and it is 52 gallons, so we might adjust that a little bit. We've got 52.5 in here. Let's make it 52, so we're going to remove 0.5 gallons off this. So click the change button. If you click it, it's going down. If you hold it, it's going up. Okay, so let's remove 0.5 gallons of fuel. Save. You can see the fuel up here. Fuel remaining has now been updated. And that is just about how you do it. The engine needs a little bit of warm-up before we can tour it up, so if you are sitting anywhere very close to the runway, then have a look at your oil temperature and your cylinder head temperature. Make sure those are rising before you actually start putting the engines to higher power settings. Okay then, let's go over the checklist real quick over here. So the ammeter is checked, radios on. Okay, transponder alt. Now that is something you do in the US. In Europe, you just put it to standby and then turn it on when you line up on the runway. In order to keep things simple, I'm going to follow the checklist over here, but that's just something for you to keep in mind. In Europe, keep it on standby. In the US, put it on alt. And that's about it. Okay then, heading indicator set. Again, a very important point. So look at this. Your conventional compass shows you heading up about 190. Your ADI must not necessarily do so. So these things drift. And if you turn this button in here down, you can change this around. And I can absolutely recommend you to check this prior to the flight, because once you're airborne, it becomes pretty hard because of all the errors you're going to have on the mechanical backup compass. But a little bit more on that in flight, maybe, if we find the time. Okay, so landing gear lamp green, and that is green. Then we've got the nav lights as required. It's daylight, we don't need them. In the night, you would turn them on to be seen better. Then we have park and brake release and brake and initial roll test, and that is the taxi checklist complete. Okay then, let's get rid of that and let's get going. Now, it is good practice to put some lights on as you're about to taxi. However, you don't have taxi lights in this airplane, so you can use the landing lights. However, if you ask 2 pilots, you're going to get 3 opinions on whether you should use them for taxi. Personally, in daylight I didn't, at night I absolutely did, but that really comes down to, well, as mentioned, you're gonna get 3 answers from 2 pilots on that topic. Okay, brakes off, plane starts rolling, brake check. Okay, let's get off those brakes again. 1000 RPMs is usually quite nice, so we can get rolling. Taxiing the airplane is fairly easy. You should keep your thrust or your power below 1200 RPMs, and that should be all you need. Taxi the airplane slowly and taxi it at a speed that is comfortable for you. So don't try to push anything here. Nose wheel steering is sufficient in order to get your airplane moving, and that is really all there is to it. So, unfortunately, some of you may have seen the windsock earlier. This is incorrect in the scenery. As we saw on the tablet, the wind is 260 at 4, so for that reason, let's go ahead and roll back. As we are doing our turns in the taxi, it is good practice to check that your instruments are working. So the turn coordinator is, the ball is deflected, and your HSI is moving as well. So let me do a little bit of maneuvering to show you what we are going to check for. Let's start slightly on the right, and okay, let's do a left-hand turn here. Moving, moving, deflected. And you also want to check that they are moving into the expected direction. Normally you will obviously simply use the standard turns that you're going to make on your taxi in order to check those. However, it is a good practice just to have that in mind, and just to if you missed it, just do it like I just did. You can always make it with a light turn, but then you're only going to get light indications. But for example, when lining up on the runway, you can still do those checks. Okay, we're getting up to the holding point, and here's the next thing. You don't just want to position your airplane straight on the taxiway when you're about to commence your run-up, because there might always be somebody behind you, and you really don't want to blow all the dust and all the little rocks that you may have on the taxiway into that direction. So it is a good idea just to turn the airplane off track a little bit. And I like to turn it into the direction of the approach, because it means I will have better visibility into the approach before entering the runway. Okay, so if you look at this, then you can see the area over here is currently covered, but if I turned the plane much further, then due to the offset holding point over here, I would really have to turn it all the way over. But like this, just make sure that there is nobody directly behind you. So that's something to keep in mind over here. Okay. Park and brake set. Then let's go ahead and read our run-up checklist. So position, they say into wind over here. Now, you cannot always do that. Like right now, we've got 4 knots of tailwind. Well, we gotta live with that. Brakes hold, fuel quantity check, but as I mentioned earlier, these gauges are notoriously incorrect, so don't expect them to show you a precise value. I'm more or less happy, you know, if I know there's fuel in the tank and I see it somewhere in about a quarter around what I would expect it to be, then I'm totally happy with that. So, as you can see right now, it's showing more or less the same quantity of fuel. We know there was a difference of a couple gallons, so that's just something to have in your mind. But then we go ahead. Fuel selectors, desired tank. So again, we knew from a walk around the right-hand tank had more fuel. For that reason, we are going to stay exactly on the right-hand tank. And then we can go ahead, mixture as required. So for the run-up, we are always going to use full mixture when we are close to the ground. When we are located at a higher elevation, you will lean a little bit in order to get your best power. But since we're at sea level, we're going to put the mixture fully forward. So throttle up to 2000 RPMs. You can use the analog gauge or you can use the digital one. Obviously the digital is going to be a little bit more precise, but personally I'm a fan of analog gauges. However, let's just check that we get roughly same data over here. So this is at 2000, this is at 2000. Perfectly fine. Again, we have oil pressure, oil temperature is good, and the cylinder head temperature is good. So, next up, we are going to check our engine instruments. That is pretty much what we just did. And we also check the gyro suction over here to be sure that our vacuum pump is working correctly. Then we go ahead with the magnetos. And the maximum drop is 125 RPMs with a maximum difference between the two of 50 RPMs. So, let's go ahead. We're at 1990 right now. We always start checking the right magneto. And we lost about 100 RPMs. Go back to both. Now we check the left magneto. Lost 100 RPMs, and there is no difference between the two. Perfect. The reason we do it is because now if we forget to move the switch back from left into both, and we accidentally turn it further to the left, we're only going to move it into the right position and not into off. So that's just a little safety feature down there that we do when checking the magnetos. Okay, prop cycle 3 times. Then reduce to 1500 RPMs and check steady. Okay. 1, 2, 3. Okay, then put it to 1500 and check that it is steady. Pretty much like so. Okay, carpet check. So we're going to pull the carpet on. Observe a little. Yeah, you can see the roughness there. And that really shows us, okay, there is something working. If you put the prop control fully forward and then do a carpet check, you will notice about 125 drop in the RPMs, like so. Okay, and that is our run-up checklist complete. So let's return the engine back to 1000 RPMs. We now know that our engine is working. Alright. If you plan to stay in here for a bit longer, you can lean the mixture a little bit. However, at this point, if you lean the mixture again, there are chances you might forget it for takeoff. So I would recommend just to keep it on maximum. Okay then, B4 takeoff checklist. Controls. Free and correct. Elevator trim, that's up here on the overhead, is neutral. Then we have the rudder trim. That's nicely hidden beyond the flap lever, and it is in the neutral position. Okay, door latched. You check it both on the bottom and the top, because this actually shows you the door is not. Okay. Now it is. Okay, perfect. Then, flaps set as desired. Normal takeoffs are done with the flaps up, so we are going to leave the flaps up. On a short runway, you can use the second notch, which is 2/3, and that's going to reduce the takeoff run by approximately 20%. Okay, fuel selector desired tank. That's still the right-hand tank. Then, fuel pump on, mixture, full ridge, prop, full forward, Carb heat off, engine gauges, check. Pitot heat, they say as required over here, but it is really good habit to turn the pitot heat on at all times. It's not going to cost you anything, but it is going to enhance your safety greatly. Okay, strobes on, landing lights as required. Well, we are obviously going to turn them on for takeoff, and that's it. Okay then, time to line up and start our takeoff. So we're clear on the approach, and that's why I like to turn the airplane a little bit into the approach during the run-up. It just gives you better visibility before you actually conduct your lineup. Obviously clear on the other side as well. Try not to waste too much runway during your lineup, but also try not to stop, because it might take a bit of power to get you going again. Okay, here we are. So let's quickly talk about the takeoff before we're actually going to execute it. Throttle full open, and we are slowly going to open it fully. Airspeed indicator alive, engine gauges check, rotate at 85 miles an hour, verify the positive climb, gear up, flaps up, airspeed 95, and emergency landing area verify. So if you go over to the left hand side, you will see that our climb power setting is going to be 2424. And we're going to set that when we're 1,000 feet above field elevation. Best climb angle 84, best climb rate 95, normal climb 120. So we are going to use 95 because we just want to climb up as quickly as we can. Okay. With that, we are ready to go. We can stow our tablet. Then remember, light wind from the front and the left. So a little bit of left-hand aileron can certainly help you after liftoff. But okay, with that we are ready to go, and we can take off. So, put your throttle in slowly and steadily. Like so. Engine instruments check. Everything's looking good, in limits. Speed alive. From about 65 at light weights, you might want to use a little bit of aft elevator if your nose wheel starts doing strange things, let me call it like that. At 85 rotate, 95 we want to climb. Okay, tap the brakes, and with insufficient runway remaining for landing, we can go gear up. Okay then, starting the right hand turn, a little bit of rudder together with the aileron. You always want to keep your ball centered down here, and you want to fly standard rate turns in your traffic pattern. Okay, getting clear of all the windmills. When we're clear of all the wind turbines, we are going to leave the traffic pattern and climb out in order to do a little bit of air work. So, passing 1,000 feet, that means we're going to reduce our power. When you reduce power, it's always throttle first, 24 inches, propeller second. Okay, 24 inches. And do note your manifold pressure will change as you adjust your propeller, so you might just about have to adjust the throttle again after you did your initial propeller setting. So a little bit of right-hand rudder is needed. You can just trim it out. You got your rudder trim down there. Personally, I do kind of like to keep the rudder in as well, but it just comes down to personal preferences. You can always trim it out. Alright, so we're climbing 95 knots. Let's go up to 3,000 feet, and then we're going to do a little bit of air work. Fuel pump can go off, and a lot of small flying clubs are going to turn off the landing lights at this moment as well. Why do they do that? Because those lights are rather expensive, and the more you have them on, the more the quicker they wear out. For that reason, small clubs do like to turn those things off. What you'll notice as you're climbing is that per 1000 feet you climb, the manifold pressure is going to drop by approximately 1 inch. That's simply due to the drop in atmospheric pressure as we climb up. So just keep in mind to put your power in appropriately and feed a little bit of throttle there. So we'll take it to 3,500 feet right now, and then we'll level off. In order to level the plane off, you basically want to start pitching down when you're about 10% of your rate of climb before your altitude. So climbing at 1,000 feet per minute, 100 feet before the target altitude, we want to start pitching down. Pretty much like so. That normally provides for a smooth level off, as you can see. So in those small aircraft, the vertical speed indicators are notoriously unreliable. For that reason, use your altimeter as your primary reference for flying level. Trim the airplane out as you accelerate, and once you have accelerated, we are going to set our initial cruising power. So cruising power we're going to get right from the charts that are delivered in the product manual. Let's have a very quick look at those. And this is what the chart looks like from the manual. So, as we are obviously just about doing a training flight, we can live with just 55% power. For optimum economy in flight, you will use something like 65%. If you want to go just fast, use 75%. But what we want to use is 55%. So we're at around about between 3,000 and 4,000 feet. We want to keep the RPMs as low as possible, as that is going to extend engine life, and that means we take something about 2100 RPMs and 20.5 inches. Let's make it 20.6. If you can set it that accurately, then congratulations, I certainly can't. Okay, so once again, in flight, reduce throttle first. Looking at a manifold pressure of something about 20.6, and then we reduce our RPMs to 2100. Be aware of the manifold pressure rising when you reduce the RPMs, so you might want to adjust your throttle again. So, it's summertime. Temperature 20 degrees. Sure enough, icing isn't going to be a problem, right? Well, not so much. Icing will be a problem. And for that reason, if you feel that you are losing any manifold pressure, it is a good idea to open the carpet for a while and have a look. So let's do that. Carpet on. We only use the carpet in short successive bursts, so to say. Pretty much like you'd use a hail on fire extinguisher. And then we keep an eye on the manifold pressure. We can see there is no increase, so we don't seem to have any carb icing. Okay. Put it back in, and that's it. Alright, with that we are established in our cruise. The first exercise for you is to trim the airplane out, because it should always be in a trimmed state. Look at that, I totally let go of my controls, and the airplane is pretty much holding its pitch. Don't look at the instruments, look outside, you're flying VFR. And if you look outside, you can see any movement much quicker than you could on the instruments. Okay, we are nicely trimmed out, so let's start with a couple of exercises. The first one is going to be to lean your power. Well, you always do that, do you? Now, A2A made a really good video on engine management in cruise, so I'm not going to go into too much detail. But here's some very quick ways. If you used your power table in order to set your cruise power, then there will also be some power or some fuel flow information on that. But you can simply use the fuel gauge as well. So I'm now starting to pull back my mixture until the fuel gauge is in the 55% area, because remember, that is what we set our power for. Here we go. And that is cruise power 55%, and the fuel is set. So that is the very quickest way to lean it out. Now a very quick look into the manual is going to tell you that in order to fly this, we need roughly some 10.3 to 12 gallons of fuel. So we are using the lower RPM setting, so 2100 over here, And that means that we have the lower fuel value as well, which is roughly 10.3 gallons per hour of fuel. So over here, let's check that. We're at 11 right now, so we might even use a bit less. Let's go to the lower side here, like so. And with that, our engine is basically leaned out. Okay then. We are going out over the water so that we can do a little bit of air work without disturbing all the cows on the ground over here, all the holidays makers over there and some interrotting. I do know that they are notoriously unhappy about noise. So, let's do a little bit of exercises here. The first one is maintaining the altitude. I absolutely failed at that since I lost 200 feet, but let's climb right back to it. Keep in mind, as we are climbing up, I'm not changing the power over here, so we are going to lose some airspeed, and that means that we'll be a little bit out of trim by the time we reach 3,500 again. So, might have to do a little bit of trimming over there. So, some comments on how you normally fly your propeller-driven aircraft. And normally, we only do standard rate turns in those, unless required otherwise. But in airliners, we normally do 25 to 30 degrees of bank. However, that is because you cannot fly a standard rate turn at those high speeds. The formula for that is true airspeed divided by 10 plus 7. So, close to the ground, our true airspeed is roughly our indicated, and that is obviously in knots, so we take the inner scale, and that is 120 divided by 10 plus 7 means 19 degrees of bank is going to provide our standard rate of turn. Now, the turn coordinator also helps. You got the marking down here, which is for a standard rate turn. So let's go ahead and fly a couple of exercises by just about flying exactly that. I'm going to set my needle over here to the initial course of 300 degrees, like so. Now we start doing some left and right hand turns, making sure that we are flying all coordinated standards. So, we calculated 19 degrees of bank, and look at that, the turn coordinator is showing exactly that. As you're initiating your turn, make sure that you're using sufficient rudder in order to fly the airplane properly. Adverse yaw really is a thing in those small aircraft, just like in the big ones, but in the big ones, you luckily got your yaw damper computer, which is going to apply rudder sufficiently when you do aileron input. So now we turn into the other direction, and the challenge in this one is that you keep your rudder in line so that you fly a smooth turn. What you can also do is banking left and right and controlling your rudder within that time. So look at that. If I'm doing proper coordinated turns, you will see that my nose basically isn't moving too much. Obviously what I'm doing right now isn't perfect, but you can get the idea of the exercise. So start practicing that. And let me just give you a quick demonstration of what it looks like when we do not use rudder. So I'm not going to use rudder. Just look outside and look at what the nose is doing. I'm turning hard left, and you can see the nose is moving into the other direction. See that? That is exactly what we want to counter with the rudder. Why does it happen? Well, quite easily. The aileron that's moving up is moving not as much, is moving more than the aileron going down, and that obviously creates more drag on one hand side, and therefore it is going to cause what we call adverse yaw. Okay then, the next thing we always want to have in mind is what happens in case of an engine failure. So always have a look at the terrain around you, especially with A2A aircraft. Those engines can fail in flight, most certainly when you mishandle them, but even when you handle them correctly, engine failures in flight can absolutely happen. So right now, of course, we got a lot of terrain on the left hand side there, but keep in mind what you may want to land on and what you may prefer not to land on. So normally the brown fields or the fields with a darker color are better places to land on. Especially looking over here, we've got a lot of green, and chances are these might be a little bit swampy, or there might be very high grass on them, which could cause your airplane to flip over on the landing. If you look at the fields we have over there, then you will quickly notice that those have been worked on by a farmer, and they are usually in a much better quality for landing. Especially if the farmer has already taken all the props off, then you have a rather good landing field. So that's something to keep in mind as you fly along. If you're flying close to water like I am right now, don't try to land on the areas very close to the shore. So if you land on here, I can almost guarantee you are going to flip over on landing, and that's going to be it. Also, don't try to land on the dikes. Especially when there is a little bit of wind blowing, this can get very turbulent, so be careful with that. Beaches, by the way, aren't a good idea either. Still better than going onto the dikes or any of those green fields over here, but if you go into one of those beaches, then chances are you are going to bury your nose gear in the ground, and that's going to cause the airplane to flip over. Talking real life, by the way, this little beach on St. Peter-Ording here has actually been the site of a landing. Somebody who ran out of fuel while on approach to St. Peter-Ording Airfield, which is somewhere over here, actually had to land on the beach. Was quite interesting. In Europe, obviously you aren't allowed to land anywhere, contrary to some other place in the world, so the aviation authority had to come, they had to specially prepare the sand for taking the plane off again, and that was a very interesting story. So try to avoid beaches as good as you can. Obviously, it's better to land on the beach than in the water. The water should be the last option, but you get where this is going. Alright then, let's talk a little bit about actually the autopilot. So the airplane is equipped with an Aztec-30 autopilot, which is the same one that I had on the very first Cessna that I flew. So let me show you how that one works. First of all, we are gonna turn the autopilot switch on over here. You can see all the lights come up and the thing is running its self-test. When the self-test is over like now, the autopilot is ready for use as indicated by the green light. So engaging the autopilot is quite easy. You press the push mode and now you've got it in ST mode. ST basically maintains your bank angle, and you can set the bank angle using that little knob over here. So if we turn it to the left, the autopilot starts a left turn. If we turn it to the right, the autopilot is going to do a right-hand turn, and stuff like that. Easy logic. Okay, the next mode we have available is the heading mode. That is the HD. So let's go ahead and center our heading block. And we're going to press the mode up here once more. And now the heading light illuminates and the thing is going to follow the heading. Once again, left and right turns, not much of a problem, the autopilot can do that. However, those autopilots are not as reliable as you may think. So general aviation stuff generally doesn't work as well as the stuff in airliners, and in some cases you would even be surprised at how some of the stuff in airliners really works. So nowadays, the thing can more or less hold the heading, but keep monitoring it. I've seen cases of an Aztec-30 just drifting off the target heading. Another thing you need to monitor, by the way, the Aztec-30 can only follow what you have on the HSI over there. But have a look at your standby compass, because the HSI is drifting over time. And you need to correct that, even in flight. So look at this. Our heading right now indicated is something about 195. If we look at the deviation scale, we'll see that 195, okay, give me something in the middle over here. So you need a degree less at 210, 2 at 2 over here, so we can say this is maybe 194 around. Now look at our HSI and you can see we're showing 220 over here. So either we didn't align it correctly before takeoff or it just drifted away. So push it in, correct it, and now we're turning back onto the actual heading. Now let's quickly talk a little bit about a couple of the problems you will have with your analog compass. Only do these checks when you're in unaccelerated level flight, because when you're pitching up or down, you're going to get different indications. The same happens when you're accelerating or decelerating. Now why is that? Well, two reasons. First of all, keep in mind how the compass works. There's a little magnet in there that is going to align the compass, but that magnet also is a weight. So as you're accelerating or decelerating, a force will be exercised on that weight. Now, depending on the way how these things are built, if it's a weight only on one side of the scale, that is obviously going to turn the scale. The other thing you have to keep in mind is the inclination of the Earth's magnetic field. So when you pitch or bank your airplane, the changing inclination can cause a change in the compass reading. So only do that when you are actually flying straight and level. I'm going to show you a little bit of what I mean here. Let's disconnect the autopilot and let's pitch it up. I have no idea if this is actually modeled, but knowing A2A probably is. So let's pitch up a bit. Look at how the reading on the scale is changing while we're actually still flying straight. Let's do the same by pitching down. Look at that. Again, the scale is slightly changing as we're pitching our airplane. Let's do the same thing in a turn. So, 3,500 feet looks good to me. Alright, let's bank it. And look at that. Look at that. We're passing 210 now, and this is showing us 240. Now let's go the other way around, and look at that. So that is something you have to keep in mind. That is really something you have to keep in mind as you are using the conventional compass. So when you have those longer straight sectors, just be sure to check your HSI drift every now and then and realign it as needed. Okay, let's put the autopilot back in. I'm going to put it into heading, and now let's also use the altitude mode. You can do it down here by pressing the altitude engage disengage button, and you can see it has authority over our elevators, but what it cannot do is trim the airplane. And in order to trim the airplane, you got the two lights over here, and it is going to show you if it wants you to trim up or to trim down. So let's go to heading mode, and now I'm going to change power, and you will see how the autopilot will try to react to it, but it will eventually run out of elevator authority and ask us to trim the airplane. So let's take a bit of power off, manifold pressure down to 15, and we start decelerating. And here we go. The uplight illuminates. You can also hear a little alarm, and that tells us, hey, I'm at full elevator authority, I need up trim. So now we are going to trim a little bit, and eventually it will stop the warning. And then it is in trim again, then it can fly again. But that is something that you have to keep in mind when you're using this autopilot. Okay, let's go back to 20.6 inches. Like so. Okay. Alright. That is basic stuff flying the Comanche. So let's use the autopilot and turn back to the shoreline and do a couple of touch and goes. In the meantime, we can already start reading ahead on the checklists. So the climb checklist we have done, the cruise checklist, throttle set, prop set, mixture lean as required, fuel pump verify off, fuel pressure check, and engine gauges check. So all of that is done. Now, keep in mind you're flying an airplane where you are primarily taking fuel from a single tank at a time. So when you're doing anything close to the ground, you want to have it on the tank with the most fuel in it. When you're cruising along, then you want to basically switch between the tanks like every 30 minutes. Now in our case, we did a couple exercises and we're flying for a little while already, so how about we go ahead and change between the fuel tanks. Now here's what we're going to do. First thing, fuel pump on. You always want that on. Second thing, tank on. Third thing, tank off. Keep the fuel pump on for a little while. There is some residual fuel in the fuel pipes, so even if you turn the tanks off, the engine is not going to fail immediately. So just wait a little bit before turning the fuel pump off again. Now let's see if A2A actually modeled that. We are probably a little far away from land, but we're in a simulator, we can give this a go. And by the way, getting a little bright outside, isn't it? Okay, so let's see if this works correctly in the A2A. When I'm turning the fuel tank off, I don't expect my engine to quit immediately, but I expect it to keep running for a bit. Let's do it. See that? Now it's using the fuel from the pipes. This can take 30 or 40 seconds before the engine actually quits. Here we go, now we're starving it. So, put the tank back on, and here we go again. So you can see, there's really a little bit of time there. If you change your fuel tanks, keep an eye on it. You can easily mess it up without immediately noticing it. Okay, so we are running on the left-hand tank now. We can see we've got a little bit more fuel over here. So do come up with a strategy how you're going to use your fuel. Okay then, let's turn back into a northerly direction. And then we talk about touch and goes and descents. So, we are planning our descent towards St. Peter-Ording airfield right now. Patron altitude is at 1,000 feet, and from experience flying I know that the airfield is roughly here. So that's the direction we're turning into. Now for the descent, typically keep the power where it is. Just pitch it down, accelerate, do a nice rate of descent. Keep in mind we are flying unpressurized, so in order to keep the rate of pressurization change not gentle to our ears, you're looking for a rate of descent between 500 to a maximum of 1,000 feet a minute. More than 1,000, I guarantee you, your passengers are going to complain. Okay, autopilot off. Let's go ahead and do that. Pitch it down a bit. Let's use something 700 feet a minute or so. You really don't want to use much more. And we simply let our airspeed build up. So for those of you who like a little bit of mathematics, you can basically do the following. In the descent you'll roughly do something like 140, 150 knots depending on your power setting. And if you take those numbers, let's say we take 140 knots like we roughly have now, then divide that number by 2. So 140 gives us something 70. And then multiply by 10 and you have your rate of descent required in order to do a nice standard rate. In other words, 3 nautical miles per 1,000 foot of altitude lost. And that's roughly going to work out over here. So if you look at that, in the descent we get 150 knots right now, divide by 2, 750 feet a minute. Now 750 is something that our ears can tolerate, and that's going to give you a nice little 3-degree descent, just like we do it on the airliners. With the single exception that on the airliners we're usually pulling power idle, while over here we're keeping the power on. So let's do a little bit of planning for our approach. St. Peter-Ording airfield is somewhere over here. The Patron altitude is 1,000 feet, and we want to reach those 1,000 feet before we are flying into the traffic pattern, because we got a low-wing aircraft. Now, visibility in the Comanche is actually quite alright, but still, there is a huge area in front of you that we are currently descending into, where you could not see any aircraft that may potentially be below you when you're descending straight into the traffic pattern. For that reason, I'm keeping a little bit offshore right now. I'm going to enter the pattern over here in a few moments, but I'm keeping a little bit offshore right now, just in order to reach those 1,000 feet of pattern altitude before I actually start turning into the traffic pattern. That's just a little thing you can do there to increase your safety of flight. Also, as we're going down, let's go ahead and read the approach checklist. Autopilot master, off, fuel pump, on, fuel selectors, desired tank. So we use the fullest tank, which is the left one, and we have actually selected that. Okay, fuel levels check, fuel pressure check, mixture, rich, Like so, prop full forward. Here's a little recommendation. All the flight manuals want you to put the prop full forward, but you can actually avoid a little bit of noise by keeping it where it is and just putting it full forward when you join the final approach. That's a technique that I would personally recommend to use, however, you don't have to. Okay, car peak as required. I'm certainly going to turn it on a bit for now, just to clear off any ice that may potentially have built. Okay, then airspeed 120 miles, gear down, flaps as desired, and that's about it. So for the landing, let's have a look into some of our general aircraft information over here. Reaching Patron altitude, 1000 feet. I'm going to pull the power off right now in order to reduce my airspeed. And then we'll enter the traffic pattern in a few moments. Okay, quick thing for you to check here. Maximum flap extension 125 miles an hour, maximum gear extension 150 miles an hour, and maximum gear operation 125. Approach flaps extended 100 miles, final flaps 85 to 90. Well, that's not a limit. That is the speed that you want to fly when you have those configurations. So approach, we'll fly it at 90 miles an hour with the flaps out, 95 with the flaps in, and that is about all we need. So once we're on the runway, we are going to retrim the airplane and then just set the trim to neutral, retract the flaps, and going to apply power again for a touch and go. So let's enter the traffic pattern at roughly 1000 feet, and we are at 120 miles an hour here. So let's go ahead and build up a little bit of drag. So flaps into the first notch, gear down, and that is sufficient car speed. Let's close it again. So our airfield is located just down here. We are entering the right-hand base, the left-hand downwind now. Do not descend below pattern altitude before you turn base, so we are going to maintain those 1000 feet. And here we go, there's our landing runway down there, and roughly when we pass the wind turbine over here, we start our base turn. As we enter the base turn, we can start a little bit of a descent. I'm going to use the second notch of flap over here. And that just builds up a little bit of drag. As always, trim the airplane out. Always have your airplane in trim. And here we go, onto the base. Our field is inside just over there. And that looks good, and now it's just all about timing. So, landing flaps. Fuel pump is on. I'm also going to put the landing lights back on. And remember, we want to fly standard rate turns for as much as possible in the traffic pattern. Obviously, if you're about to overshoot and you have sufficient airspeed like I do right now, you can use a little bit more bank, but try to plan your turns as standard rate turns. Okay. So down we go. How do you fly this? Well, elevator for altitude, throttle for pitch. I know that in many clubs they say the opposite, but believe me, that's just to make it easier for general aviation pilots. Once you start flying professionally, on any airplane they will tell you to pitch for altitude and power for speed. Pretty much like so. Okay, so we are doing 90 miles an hour, that looks good. So, power idle, expect the nose down moment, and then we can flare it out. And we're down. Okay, flaps up, add a little bit of power, trim back to neutral. Like that, and smoothly go back to full power. And rotate. Okay, climb once again at around 95 miles an hour. And left-hand turn, let's avoid the city. Again, using a standard rate over here. So, gear up. Again, only raise that landing gear when you are sure that you are no longer able to land straight ahead, so like I did just now. Okay, remember, 10% of your rate of climb prior to the altitude where we want to level off is going to be your level off. So we're doing about 1,400 feet a minute over here, so 140 feet to go. We start pushing the nose down. Okay, and let's enter the downwind. So I'm going to reduce the power to something like 2020. I did figure that works quite well in the traffic pattern. So 20 inches manifold and 2,000 RPMs. Trim the airplane out, and that was our first touch and go. We can surely do better, but you get where this is going. After all, we are practicing at the moment. Okay, so back down to the... Okay, here we go. So maintain 1,000 feet, and then power to idle. Or not exactly to idle, but reduce the power, as we have just about passed the beam the landing runway threshold. And once our speed allows, we are going to extend the landing gear and the flaps again. Okay, gear down, flaps onto the first notch. So, passing abeam the wind turbines, let's start turning base, and then we can also start our descent. Okay, flaps 2/3. Always have a good look outside. I know it is difficult in the simulator, but you are really going to fly better the more you see your airfield. And remember, standard rate turns. Okay, flaps full and the fuel pump is on, and with that our preparation is completed. 90 miles an hour is what we want to fly. Okay, let's start our final turn. And again, watch the bank angle over here. That's quite important. Alright. Established on the final, get the speed under control, get the glide path under control. You basically want to keep your runway at the same spot in the window at all times, and that is going to provide you with a very good and stable approach. Pretty much like so. It takes a little bit of practice to judge the angle correctly at which you want to approach, especially when you have runways of all kind of different length and so on, but it certainly is something that you want to keep a good eye on. And remember, every single power change is going to cause the airplane to get out of trim, so anticipate that happening. Okay, power off. And we're down. So, flaps up, introduce a little bit of power not to lose too much airspeed, trim back to neutral, and full power. .85 knots, and we're flying. Positive rate of climb, gear up. Okay, this time we are going to climb a little bit higher, and we are going to do a spot landing. Now, spot landing means that we are going to fly 2,000 feet over the field elevation, and then going to go throttle idle and pretend that we are simulating an engine failure and we want to land the airplane from that situation. So that is a little bit of practice that we do in single-engine aircraft in order to prepare a pilot for the case of a total engine failure. So we're climbing up to 2,000 feet. Remember, in the climb passing 1,000, what do we have to do? Right, manifold pressure 24 inches and the RPMs back down to 2,400. Like so, and the fuel pump can go off. Okay, that's our field down there, climbing up to 2,000 feet, and when we're stable in 2,000, we're going to more or less fly the traffic pattern on the top, but we are going to overfly the field like so, and then when we are over the landing runway threshold, we're going to pull off the power in order to start our maneuver. Okay, 2,000 feet. Let's go to normal cruise power setting in order to have a decent amount of speed, as would be realistic for a scenario like that. So, what did we use previously? Like 20.6 versus 2,100 RPMs. Like that. Okay, so that's our cruise power setting, and let's make our turn back to the landing runway. It is a little bit difficult to judge when exactly you are over the runway, but in order to judge that properly, I would recommend to have a look at the runway and then pick up some marks that are adjacent to the landing runway threshold, so that you can simply look out to the left or to the right and then decide on the amount of decide on the exact position where you are over the threshold. So in our case, let's quickly align the airplane with that runway. I'm probably overshooting a bit. Yep, I am. So let's have a look. When we are being the landing runway threshold, we got the buildings over here. We can extend it to the bay over here. So that's the spot we pick for judging where we are going to be directly beamed. So back down 2,000 feet, that's where we're going to start the maneuver. You can see I'm still kinda getting used to the plane as well. So that's 2,000 feet, and we are abeam the bay, so throttle idle. First thing, pull up and reduce to the best gliding speed. You want to conserve as much energy as possible. And if you don't remember what your best gliding speed is, have a quick look into the tablet. And you have it down there. So, best glide in terms of range is 105, endurance is 90. So we take 105. Well, we can take 90 as well. Both of them are going to work. Okay, so now comes the exercise. Keep your airfield in sight at all times. Now you can sort of time it. Like, we gained initially some 400 feet, and now we're going to fly the upwind until we are roughly something like this. Okay, also keep in mind the wind as you're flying a maneuver like this. Let's turn downwind. And at this point you can start judging, okay, how far from the field am I? Keep in mind that on the downwind you have a tailwind, while on the final you're going to have a headwind. So don't fly out too far. At this point you can also cut the corner a little bit in order not to fly too far away from your landing runway. So we've now lost half of our altitude. We are just abeam the landing runway threshold, so that means we are roughly in a good spot. Okay, let's not overestimate ourselves. We can always lose some altitude by using the gear and the flaps, but we cannot gain any altitude in this exercise. When you're close enough to the landing runway that your landing is assured, drop the gear. I would say that is assured now, so let's put the gear down. Okay, here we go. We might be a little bit high, let's use some flaps in order to gain a little bit extra drag. A little bit more flaps maybe. Second notch. Okay, full flaps. And here we are. When we're on the ground, we'll do a touch and go. If you come in a bit high, you can do a side slip. Like so. Okay, out of the slip. And that looks alright. Okay, flaps up, full power, rotate. And here we are, in the air again. Okay, so, gear up. I think the exercise became clear. In case you have an engine failure, we want to start at the standard position and want to be able to pick any location for our landing. And that is what we are practicing with this exercise. Okay then, we have done pretty much everything that we wanted to do. There is one thing left, and that is going to be handling of stalls. Now, in an ideal scenario, you would start practicing that before you do your touch and goes, but with an instructor next to you, you can really do both. Okay then, let's start heading back towards Heidebusum, where we departed from, and do our... bring our lesson to an end. Okay, passing 1,000, again, climb power, 2424. Like this, and the fuel pumps can go off. Perfect. Alright. And that is pretty much all it takes in order to fly a Piper Comanche. So, once we're over the water, we are quickly going to do a little bit of stalls, and that is really going to be it then. So, stall. Well, we're going to do two different scenarios. One of them is flaps up, the other is flaps down. You can do both power on and power off, but for our training scenarios today, we're simply going to do power off stalls. Climbing up to 2,500 feet, well, let's actually make it 3,000, because when you are doing stall exercises, you want a little bit of altitude below you. So, on the first indication of a stall, which normally is the light over here, you would obviously just lower the nose, thereby reduce G-loading, and that is going to get you out of the stall pretty much immediately. Indeed, provided that you didn't trim the airplane for a stall, the moment you let go of the control column, you will normally be out of it. In the past, there used to be some rules that for stall recovery training, with the flaps up you should not lose any altitude, with the flaps up you shouldn't lose more than 100 feet, and with the flaps down you shouldn't lose any altitude. That rule has been abolished, because the exercise is to safely leave the stall area. That is all that counts. If you can minimize the altitude loss, okay, but there have been too many cases where people crashed because they pulled secondary stalls, and we absolutely want to avoid that. Okay, so, I'm going to reduce my power, 2100 RPMs, and let's go 15 inches manifold, and just about trim our airplane out for the present conditions of flight. Let's see where it's going to stabilize. Okay, looks pretty stable to me. Alright, very nice. Then let's go ahead and reduce thrust to idle. That's the gear warning horn you hear there. And we are just about going to maintain level flight. You will feel how you need more and more elevator. When you're in slow flight, only use the rudder in order to keep directional control. Do not use the ailerons, as that can introduce a spin. Okay, we see the stall warning light. Pitch down, power. And be careful not to pull a secondary stall. That's it. Okay, let's do the same a little bit more aggressively this time. This time I'm going to pitch it up 20 degrees. Power idle. And this is what happens if I just keep the nose up. See how gently it stalls? So, lowering the control column back to neutral. And we are right out of the stall. Okay, that's about as easy as it is. So let's do the same with the gear and the flaps. Reducing speed a little bit. Okay, gear down. First notch of flaps. Second and third. Idle. Stall. Pitch down. Power. Be careful not to pull secondary stall. And here we go. That's as easy as it is to recover the Comanche. Alright. Gear up. Flaps up. And that is all our exercises complete. So, power we set 20.6 at 2100 RPMs. Pretty much what we have now. So let's return to Heide Büsum for our full stop landing. We are rather close already, so for that reason I'm going to reduce my power a bit. Normally when you're doing a normal cruise flight, you would just keep the cruise power for your descent, as that would make your life a lot easier. Okay, let's do 1000 feet a minute. We really don't want to do much more. Patron altitude in Büsum is 800 feet, and we are going to fly around a couple of the wind turbines. So it's quite a spectacular approach, seeing how close you actually get to those wind turbines. A final word here, as we did a lot of flying in areas close to the shore, and I know that flight simmers do like flying close to the sea. So when you do that, try to avoid overflying the coastline below 2000 feet altitude. The reason for that is that below 2000, the risk of a bird strike increases exponentially. And bird strikes in these aircraft really are not good things. If you can avoid them anyhow, then do try it. Okay, going right over the dike down here. And that means we're past the shoreline. So let's continue our descent. So our airfield is just over here, and we are going to join the right-hand downwind, which is just to the north of the wind turbines that we see over here. But remember, we should not descend into the downwind, so let's just about turn off track a little bit more. Just to be sure that we do not accidentally fly into anybody. Continuous descent approaches, after all, are a thing for airliners, not for general aviation. Okay, before we land, let's use a little bit of carb heat there to get rid of any icing that might have built up. Okay, this looks about right to me. The downwind is over there. Let's go down to 800. Get the speed under control. Okay, the downwind goes between those wind turbines and the little city over there. And we now have everything in sight. We now know we aren't crashing into anybody. So we are good to go. Okay then, field is over there. We are at the Patron altitude. I'll let the speed bleed off. Like so. Okay, a little bit of power, maintain the 800 feet, and then we're established in the right-hand downwind. We're going to fly past the wind turbines over there, and then we'll go in like this, pretty much. Okay, I want to see a perfect traffic pattern now. And indeed, this is looking alright. We are at 800 feet. We're at the speed we want to be. So let's reduce a little bit further that we can extend the landing gear. Okay, gear down. Flaps into the first notch. Maintain pattern altitude. And when we are clear of those buildings, we are going to turn base in between here. Okay, can slowly start our descent, just gently. So, flaps full. Fuel pump on. And that's it. Okay, over there is our field. 90 miles is what we're looking for. Okay, let's turn final. Now it would be nice if we could actually see something. There we go. Okay. Our altitude looks good. Our course looks good. Nice. All right, we are established. So, everything stable, trim it out. And we are close enough, pull the power. Alright, we're down. I'll let it roll all the way to the end. I don't think I'm going to need any braking here. And indeed I don't. As you decelerate the plane, keep an eye on your power. You don't want the engines to go much below 800 RPMs, even though it can. But it's a bit better for the engines to keep it at about 1000. Okay, runway is vacated. Let's clear the runway completely, get the entire plane off, like so. And then let's quickly stop in position in order to run the after landing items. Okay, after landing checklist, flaps, up, strobes, off, fuel pumps, off, mixture, lean as required. I am going to lean this a little. And trim to neutral. Here we go. Okay then. Let's taxi in, and when we're on the parking position, we are going to shut it down, and that is going to conclude the tutorial. I surely hope that you learned something on this. Very much looking forward to read your comments, and I'm sure that there will be some great suggestions as well as to what I can improve on my flying. And I am really looking forward to see you fly in the Comanche. I believe I'm probably repeating myself, but I can't overemphasize it enough how great of an airplane this is. Okay, let's park it over here, and then we'll just push it into position. Okay. Brake set. Let's get to the shutdown checklist. Park and brake set. Radios off. Then transponder off, avionic master off, master switch off, throttle closed, mixture, idle cut off. Magnetos off, control wheel secure. Okay, doors and windows closed, tie down secure, shutdown checks complete. So, very quick word here on the shutdown. When you shut the airplane down, then you absolutely want to cut the mixture before you turn off the magnetos. The reason for that is that any remaining fuel in the engine is going to be burnt off. If you stop the engine by turning the switch off, but have the mixture still on, then you simply cut the ignition, but there will be remains of fuel in the engine. Now imagine what would happen if somebody would turn the propeller, create a little spark inside, which might ignite the engine for a second, and just turn the propeller a couple of rotations. That can easily cost you your arm or your hand. So be very careful that you always cut the mixture first and the magnetos second. Alright, so that is our flight completed. Now, let me show you a quick thing there. If we go to the controls and put the tow bar in position like so, then we can now tow the airplane. So, park and brake obviously needs to go off for that. But now, by just using my control wheel, I can actually push my airplane. That's quite cool, isn't it? And that's the reason why I just about stopped on taxiway, instead of trying to fiddle myself into the parking position here. So that's quite cool. I'm using down elevator on my control wheel right now, and a little bit of aileron, and that is how I'm steering it in. Okay. Pretty much like so. Are we clear? Yeah, we are well clear. Might even just tow it forward a bit again. Alright, that looks about good to me. Perfect, and that's it. So, that is pretty much the standard flying procedures in the Acusim Comanche. I hope you learned something today. Do let me know in the video and comments below, and I'm very much looking forward to see you all again on the next one. In the meantime, enjoy your flights and build up your skills flying this airplane. It absolutely is worth it. It really is. So do check this airplane out. It is an absolutely great one to fly. I would like to thank you very much for joining. Hope you enjoyed it. If you did, do let me know in the comments below. Leave a like to the video if you really liked it, and subscribe for more. Thank you for watching, and I see you all again on the next one. Finally, if you really love the channel, I would appreciate a small donation through the Buy Me Coffee link that you can find in the video description below. Alright then, see you all on the next one.